Okay, folks, some practice questions now on solving contextual problems with the normal distribution. Okay, so what we're going to do is we're going to focus on developing a solution strategy and solving involving percentages and areas. Well, we sort of built all that already, so let's just put it into practice with some test type questions. So the assessed value of housing in Stephenville. Oh, everybody loves Stephenville, one of my favorite towns. Whoops, it says the assessed value of housing in Stephenville is normally distributed. Okay, so we have a normal curve. There are 3,000 houses. That seems like a bit of an underestimate for Stephenville, but we'll take it. With a mean assessed value of 170 grand. Okay. The standard deviation is 12,000. How many houses have an assessed value between 182,000 and 158? I bet if we draw ourselves a normal curve here, we're going to be in business. So, important information, mu is 170,000. That's the mean. And sigma, which is the standard deviation, is 12,000. Okay, so we're going to draw a normal curve here, bell curve, and that's really not all that symmetric, but I'm no artist, as you know. So we got 170,000 in the middle, and let's just draw a couple of standard deviations out and see where we end up. So one standard deviation out would be 182,000. And one standard deviation below that would be 158,000. And I don't think I need to go any more, because if I look at the numbers they gave us up here, they said how many houses have an assessed value between 182 and 158,000. Well, we know that if it's within one standard deviation, which is what we've done so far, then that should tell us that it's 68% of the houses. So if there are 30,000 altogether, what's 68% of 3,000? That's what we got to figure out. Well, let's see. 0.68 times 3,000, or 3 times 68, let's see, is going to be 2040. So we got 2,040 homes, and it looks like that was an easy problem to solve. I think perhaps the other distractors that are given here, yes, in fact they are, those are things where they want you to look at sort of the wrong number of standard deviations if you didn't know your percentages. So got to know those. Alrighty. Jericho writes the public exam. That's a cool name. Jericho writes the public exam for Math 3201. The average score in the exam was 65%. So there's our mean. And the standard deviation was 11%. Okay. What grade will Jericho need to achieve to score better than 97.5% of the students who take the exam? Whew. Okay, so let's think about that for a second. 97.5%. Well, if we think about that, we know that within 2 standard deviations of the mean, we've got 97% of the data. Okay, so within 2 standard deviations, we've got 95% of all those who are going to take this exam if it's normally distributed, right? Okay, so that means I've got 5% hanging out in what we call the tails of the distribution here. So if I've got 5% out there altogether, I've got 2.5% in either end. Okay, so if that's the case and I have 2.5% in either end, then if I look at this one over here, 2.5% up in this tail, then that means I've got 97.5% that scored below that number. That's exactly 2 standard deviations above the mean. So if we take our mean, 65, and we add 2 standard deviations, which is 22, we end up with 87% as a grade that you need to score on that exam. So that 97.5% of the students who took the exam scored lower than you. So 87. It's a good grade. Wow, 87. Okay, so I think those are our 2 examples. Remember, read the problem carefully, and I can't emphasize a couple of things enough here. Make sure you sketch a normal curve. It helps so much. Plot the important values and percentages if you can. Understand what the problem is asking, and do the simple arithmetic. The arithmetic is the easy part. It's figuring out what you're supposed to do. That's the hard part. But I have faith. All right, hope that helps. Good luck.